Okay, so we talked about some other number systems, additive systems and multiplicative systems, and now sprinkled throughout history. So this wasn't necessarily linear development of numbers. Sprinkled throughout history are examples of what's called a positional system, which, by the way, is what we use right now. The Hindu Arabic system is a positional system, and I'll try to explain to you what that means. So in a system of numeration, okay, first thing to note is that a quantity that answers the question how many of something is called a number. A number answers the question how many, and that's contrasted with what's called a numeral. A numeral is the symbol used to represent the number. So as we were looking, as I just mentioned, as we were looking at the additive system, the Egyptian hieroglyphics and things like that, the numbers, the value is the same, but the numerals, the symbols that represent those numbers are different. Okay, but they would have communicated the same thing if you know. And so what we're examining and what we've already started examining is what's called a system of numeration. Consists of a set of numerals and the rules for combining the numerals to represent numbers. Okay, we've already looked at some of the rules in like an additive system. So what are the rules that we are under in our system? And that's a really great great question. So in what's called a place value system of numeration, the value, a numeral, remember, a numeral is a symbol. The value a symbol represents depends on its position. So for instance, how we encounter this is these two numbers use the same symbols, okay, but they mean different things. So if I write down 30 or if I write down 300, that 3 is now communicating to you something completely different, right? Because it's in a different position. That's what it means to be a place value or a positional system. Is the numerals, we only have 10 numerals in our system, 0 through 9, but we use them to create an infinite amount of numbers because of the places that those numerals represent. And so again, I mentioned this earlier, what that's called, what our system is called over the course of history, it's called the Hindu Arabic system. Okay? And it is base 10, and that is called a decimal. Uh-oh, I ran out of ink. That's called a decimal system. So my base 10 system is called a decimal system. So I just want to illustrate for you what this means, okay? Because what we're going to do is we're going to take this knowledge, okay, about what a place value system is, and we're going to go back in time to two of the original that came into being completely separately as far as we know, okay? So for instance, what we're going to do in example 1 is we're going to take this Hindu Arabic number, 24,659, and we're going to write it in expanded form. Okay. And actually, when I do this, I'm going to start over at the right-hand side at the units. So the 9 is in the ones place or the units place. So what that means, and I'm just going to come over here, I have 9 times 1. I have 9 units. Now help me out with your understanding of our place value system. What does the 5 represent? What place is the 5 in? The tens place, right? So the 5 represents 5 times 10. Right? Are you with me? This is something you learned way back in elementary school, and you probably haven't thought about it at all. You just take it for granted now because you've been immersed in the Hindu Arabic system. The 6 represents what? hundreds, right? 600s. Now I'm going to write this a little differently. I'm going to write this 6 times, I'm not going to write 100. I'm going to write 10 to the second power, which is 100 if you go to your calculator. And what I want to show you, what I'm illustrating, is the pattern that we have in our place value system. And then the 4 is in the thousands place. But instead of writing 4 times 1,000, I'm going to write 4 times 10 to what power do you think the 10 is going to be raised to now? The third power. And then finally, the 2 is in the 10,000s place. And so I'm going to have 2 times 10,000. But instead of writing 10,000, I'm going to write 10 to the fourth power. And what you see in our positional system is each place value is 10 times the previous one. This is 1. The next one is 10 times 1. The next one is 10 times 10 times 1. So it just goes 10 times the previous one. Does that make sense? And if we kept going, the next place value would be 10 to the 5th, and then 10 to the 6th, and on and on and on. So what I would like you to do, please, is just duplicate that same sort of thing in exercise 1. Write 3,769 in expanded notation like I did. All we're doing here is practicing getting used to what the positions are communicating to us. Okay, so again, I'm just going to go from right to left. I'm going to start with the units place. So we've got 9 units. So 9 times 1 is where we start. And then the 6, how do you represent how are you going to write down what the 6 represents? Okay, 6 times 10, great. And then plus, and then how about what the 7 represents? 7 times 10 to the second, 700s. Yes, and then finally 3,000s. So that's 3 times 10 to the third. We doing okay? Yeah. When we write expanded notation, and this is going to matter, it's a great question. In case you didn't hear, question was, can I do the units over here and go left to right? Right? Is that what you meant? Or yeah, we wouldn't do that because the place value, the places have meaning, and the way we do numbers is we do the bigger part on the left and move to the right. So we're going to stay like that because that's going to matter for doing conversions and systems we're going to be less familiar with in a little while. So just because I wanted you to have as much fun as possible today, go ahead and do the same thing for exercise 2. All right, so I just did the busy work right here, which is really all this exercise is. Again, I'm just trying to reinforce what a place value, and in our case, the decimal place value system is. So I've got 4 units, 4 times 1, and then plus 3 times 10, plus 9 hundredths, so 9 times 10 to the second, plus 5 thousandths, 5 times 10 to the third, plus 6 10,000s, 6 times 10 to the fourth, plus 700,000s, 7 times 10 to the fifth, and finally 3 millions, 3 times 10 to the sixth. Okay, so after that labor, are we doing okay on what our decimal system represents? Okay, so now exercise 3, you're just going to go backwards and just be careful. Okay, make sure you're including every decimal place. Okay, I might have tried to get tricky with you on exercise 3. So the 7, as I'm reading this, the 7's going to represent what? 7,000s. Now, do I have anything written here in expanded notation for hundreds? No, we skipped that. So what do we put when something's missing? Yeah, we can't just put the 5 next because 7051 and 751 are completely different things. Okay, so we have to put in that 0 to represent that we skipped the spot, which, by the way, you might take that for granted, but the development of the number 0 is a very recent invention in the history of human beings. Okay, only in the last 1,000 years or so did anybody decide that if you didn't have anything, that it was worth having something to represent. Like, in fact, the next system of numeration we use didn't have a 0. So when we look back, archaeologists look back, it's sometimes hard to transcribe what the number value was. It would have been clear in context, but for us, thousands of years later, it's not so obvious. Anyway, so we've got 7,000, and then we've got 50, and then 4. So 7054. Okay, one more. Exercise 4. Go ahead and do that same thing, please. Okay, so in this one, I've got 3 units. This one skips the tens place. Then I've got 500s, and then I skip the thousands place, and then I have 3 10,000s, and then I have 800,000s, and I'm going to put a comma there as we tend to do every group of 3. Okay, so 830,503. We still doing okay? All right, so how we're going to end our time in this section is we're going to look at 2 occurrences, and there were others, but 2 occurrences of positional systems of numeration before the Hindu-Arabic one. Now, Hindu-Arabic, we're base 10, we're decimal. I'm guessing that's because we have 10 fingers, and it just made sense to count things in group of 10, but that, again, that wasn't always the way people thought about numbers. So the oldest known positional system, the oldest one that we have found, was used by the Babylonians. Now, history is not my strong suit, but the Babylonians, they existed long before the Romans and the Greeks did. Okay, in the Middle East area, they had one of the great world empires for a long time, and they were also amazing astronomers. And so that kind of is why I think that instead of each position representing a power of 10, like we do, this system is what's called base 60. Because probably they were really familiar with using circles and angles. Okay, and they had divided up things into 60s. And this kind of thing, I'm including this because it's a fun word to say and spell. This is called a sexagesimal system. That's a mouthful. Okay, instead of a decimal system, it's called a sexagesimal system. So now instead of the places being represented by your units and then your tens and then your 10 squareds and 10 thirds and 10 fourths, the way the Babylonians viewed the world and the way they used numbers is, again, their rightmost position would have again been their units. But now as they go to the left, the next, instead of, again, they're not base 10. They would not have been groups of 10. Their next one would have been groups of 60. Then their next place would have been groups of 60 squared or 3,600. Then their next place would have been groups of 60 to the third. Their next place would have represented things 60 to the fourth. And now I'm going to stop. I'm going to write an ellipsis on the front because they would just keep going like we keep going. Same pattern, but instead of groups of 10, they use groups of 60. Now, one of the things is they only had two symbols. Where we have 10, they only had two. They used a V, okay, because they were using reeds, into clay tablets. That's what we have from them. So the end of the reed was shaped like an angle. So they would have oriented the reed like this for one, and then they would have oriented it sideways to represent tens. And those are the only two numerals that they had. So for instance, example 2, my example, we're going to take these three places, and we are going to write this in Hindu Arabic. Now, what the assumption we're going to make is that these don't skip much, much later in their history. Okay, this was toward the end of their empire. I must have had confusion, and they started to use a little dot to represent skipping a place. But for most of the history of the Babylonian number system, they did not. So we're not gonna worry about that. So here we go. We're gonna write this as a Hindu Arabic numeral, and to do this, to convert another base to base 10, we use expanded notation, just like we were using and practicing with our decimal system. Okay, so here we go. We're going to start over on the right, just like we did for decimal system. And so I've got two marks that are left. Those are each 10, so 10, 20. I've got two that are down, that's 2. So what that means is this place, since it's the one that's to the right, that's my units place. So I have 22 units. Now the next place, and you can just look up above the table where we just wrote this a minute ago. The next place, as I go to the left, is going to represent groups of what? 60. Yep. So what I have here is I have 10, 11. So I have 11 times 60. I have 11 groups of 60. Plus the next place, as I go to the left, the next place is going to represent groups of what? No, we started with ones right here, and then we did groups of 60 right here. So the next one is going to be groups of units, 60s, not 600, 60 squared, which is 3,600. So now I'm going to have 1, 2, 60 squareds. And at this point, the problem just becomes a calculator problem. So you get your calculator out and you're like, okay, 60 squared is 3,600 times 2, that's 7,200. Plus 11 times 60 is going to be 660. And then 22 times 1 is 22. And that is going to give me a grand total of, let's see, 2. And then I've got 8. And then I've got 6. I've got another 8. 7,882. So we're going to practice this a few times, and then we're going to talk about the other system of numeration, and then we'll be done with this section. So exercise 5, I want you to write that number in Hindu Arabic in ours, and there's 4 places. Okay, so you got one more place than the example that I just did. All right, so I'm just going to start writing this in expanded notation. If you have a question or a why I have used something, please let me know. I know that this is new and different and strange, thinking about numbers the way other people groups did. And so here we go. This first one right here, I've got 1021 units. So I'm going to write 21 units right there. Then the next one, I've got 1, 2. I've got 2 groups of 60. So there we go. And then the next one is I've got 1 group of 60 squared. So there's that. And then plus, and then I've got 10, 20, 60 to the third. So that's going to be a pretty large number when I go to my calculator for that. Okay, so let me grab my calculator. So 60 to the third. 60 raised to the third is 216,000, so a lot, and I'm multiplying that by 20, so that is going to be 4,320,000, so that's quite a bit. 1 times 60 squared. 60 squared is 3,600, so that's 3,600. 2 times 60 is 120, and then 21 times 1 is 21. So that's going to be the 4,320,000 plus 3,600 plus 120 plus 21. That is going to be 4,323,741. Now, if you didn't quite get that one, the good news is there's going to be another one, and you can ask whatever question you need to. So go ahead and do exercise 6, please. All right, so I'm going to go ahead and write this in expanded notation, compare your notes with my notes, ask whatever questions you have to ask. So again, my units, I've got 10, 20, 31 units. Plus, here in the middle, I've got 10, 20. And what does that middle represent? Those are groups of what? Not tens. That's us. 60s. Yep. And then this end one, I've got 1, 2, 3, and that is 3 groups of what? 60 squared. Yep. I know it takes a second to get used to. You got to really think, okay, I'm not base 10, I'm base 60. It will make you go crazy a little bit. I understand. Okay, so that is 60 squared is 3,600 times 3. That is 10,800. Plus 20 times 60 is 1,200, and 31 times 1 is 31. And when you add those numbers together, you've got, we've got 10,800 plus 1,200 plus 31. That turns out to be 12,031. All right, one more. This is going to be our last example for the day. We'll do the last page of this when we come back next time. And I'll tell you what that means for your homework after we do this problem. So exercise 7, go ahead and convert that to Hindu Arabic, please. All right, so one more time, we have a number that has 4 place values in the Babylonian system. We are converting this to a number in something that we understand because we look at that and we have no idea what the size of that magnitude, what it means. So here we go. So my units here, I've got one unit, so 1 times 1. Then I've got 10, 11, 12, and that's 12 groups of 60. And then I've got 10, and you told me a minute ago that's 60 squared. And then finally, I have 1, 2, and that last position out there is groups of what? I'm sorry? 60 to the power of 3. Excellent. Well said. And so once you've translated it into expanded notation, it just becomes at this point a exercise in using your calculator. So I have 60 to the third. 60 to the third, it was a large number. It's 216,000 times 2. So that is 432,000. Plus 10 times 60 squared. 60 squared is 3,600. So that is going to be 36,000. 12 times 60 is going to be 720, and 1 times 1 is 1. And now my last thing I'm going to do is I am going to add up those numbers. So I have the 432,000 plus 36,000 plus 720 plus 1, and that equals 468,721.